Hi everyone, thanks for joining this session. So today we're going to talk about solving the never-ending requirements of authorization, a topic which hopefully has rung a few bells and maybe put some fear into some of you of past experiences. But hopefully I have a solution to hopefully solve these pains. So quickly about me, I'm Olivier. I'm started out life as an engineer and kind of moved over to the dark side of product management, but still very much writing code day in day out. Started out at Microsoft, so did the whole enterprise thing, but then very quickly moved over to the world of SaaS and crazy startup life, as I'm sure many of you are as well. Worked at Martech, e-commerce, supply chain, and even fitness, which if you see me, you may not believe. But I've always been very kind of data and infrastructure focused rather than kind of the more UI and workflow side of things. And that kind of always led me down to the world of backend systems and backend services required to run, like authentication, authorization, and kind of ran into this pain over and over. And I'm now currently working on an open source project called Servos that solves authorization headaches, but I'll come on to that at the end. So first off, just to clarify, make sure we're on the same page. Today we're going to talk about authorization with a Z or a Z, and not authentication with an N. So authentication is about making sure the user is who they say they are. Authorization is then making sure that the user or service is doing the things that they're allowed to do or authorized to do. That's authorization. So very overused quote, but in this world, nothing is certain besides death and taxes. And having been that long-suffering product manager across various different verticals and industries, I'd like to extend this and add in that the ever-changing authorization requirements also are pretty much certain in this world. This is just a factor of fast-growing, fast-moving startups, but also larger enterprise systems where requirements always change based on building new services, building new systems, or a number of other factors. And hopefully this will ring some bells. So in the early days, you built a system out and you got sort of blissful day of roles, as we call it, where you got very simple. You have a kind of organization, you have a system, and you're opening it up to users. And you start out with a very simple check where you say, right, if the email address that the user is authenticated contains at mycompanies.com, then they're admin and they should be allowed to do stuff else. They're a user, thus they can do a subset of stuff. This is very basic authorization. I think we've all written this at some point in our code bases just to kind of get things working. And this is great when you have very basic requirements. You just want to show maybe like an admin dashboard to your users, and you want to then only show that to your admin, and then your users get access to the normal app. And if you were to kind of implement this using a more of an authorization servicey type model, you maybe just use something simple like OAuth scopes. So actually putting inside of your authentication token whether this user is an admin based on some conditional logic, such as whether they have an email address that matches your domain. Very simple. Now things are going well and you're kind of growing up a bit and you're on to the next stage. You got a product and you got maybe a different set of features in there, and you kind of start building out a sales team. And after a year of selling your system one way, your sales team come along and say, right, we should actually change our product packaging because there's a more optimal way of selling this, so I think we can get more value by gating certain features, etc. Which is great, but now you're going to have to understand who the user is, what package they're on, and what features that they're matched to. And so you might go and implement something like this, where you can only see the premium feature, where you have the user's email is sort of the company, so admins can always see it, but then the company of the user or the company package is set to the premium, thus they can access the premium features. And this is kind of the most simplistic form where you might have a couple of packages, but as you scale and as you grow to kind of more larger enterprises who feel they can buy whatever features they want, you'll end up with these contracts and these deals which require, yes, this person's on the premium package, but they've also got access to this one extra feature which is only in the platinum package. And you now have all this kind of conditional logic to include, or a very typical one is you're coming up to renewal and you want to give a 3-month trial of the higher level package to that customer to hopefully get them renewed. And now you're going to have to kind of bake that logic in. And the common use case is kind of using a feature flag system, like say Launch Darkly or something like that. But the complexity in here is around how you model it and how you understand who has access to what in a scalable fashion. And so this if statement is going to become quite complex, where you're now going to have to start checking for whether they got a trial or they got access to a special feature, etc. Keep growing, and now as a business you decide to move out to another region. So you say you started in the UK and you're in Europe, and now you want to kind of launch in the US, and you're doing kind of data processing and data storage. You're now going to run into all sorts of fun things around who has access to which data, and data protection laws, data security laws, where an employee in the US isn't allowed to access the data on an EU citizen, or vice versa. California has their rules also. So now you're going to have all these authorization checks also to make sure that the access of data from certain regions is going to be allowed, and you have all the correct controls in place, and more importantly, you can prove you have those controls in place to anyone that wants to do an audit or a pen test or anything like that on you. So you'll have some conditional logic now which says, okay, is the resource or the user region matching? If so, they're allowed. If not, they're not allowed. This also applies to support teams. So if you're a SaaS platform and you have a support team based in the UK and the US, you want to make sure a US support team member can never access a UK or a European account, or vice versa. So you're going to have more of these logical checks in there. And now this is where things get a bit tough. So you could maybe use OAuth scope still, but now you're going to have EU and US versions, let's say, of the permissions based on the region. And there's kind of policy or authorization frameworks that you could embed inside your monolithic application, like Castle, or if you're in the JavaScript world, or can, if you're in the Ruby world, to kind of start extracting some of this logic out. But at the end of the day, inside your code base, there'll be some logic like this. Stage number 4 is like, okay, right, you solved the data locality problem, you solved the data access problem, and you're going to start selling to enterprise organizations. And as a small startup, selling to enterprise organizations, you can't just give every user in an enterprise access to everything. That's just not how these companies are built. That's not how these businesses are structured. You'll have sales and marketing and support teams in an organization that's then split by region or by office or by various other facets. And they all need their unique access and kind of lockdown access to make sure they can only see what they're allowed to see, but then you'll also have the managers and the management team. You want to be able to see everything across organizations. And now this complexity gets introduced, and you're going to have to start modeling something like this, where you maybe have groups, and you want to make sure users only have to have the Platinum package and they're in the manager group, for example. And maybe you could use some kind of directory attributes which you ingest from like a directory system, and LDAP or Okta, something like that. And then you're going to have to write this custom logic, because each of those LDAP or Okta instances are going to be unique to that user. And this is going to start scaling. A bit of a headache, and you're going to have to do this for every customer. And this logic is going to keep growing. And then finally, you've kind of grown even further, and you're now at the stage where, right, we want to go and really sell to enterprise. Let's go and get our certs and get our compliance. And you maybe have hired a chief information security officer. So you go, right, we're going to get our ISO 27001 or our SOC 2 compliance. This is not a simple task. I've been through these a couple of times now, and the bar is quite high for what you have to do. And one of the big things, and I have night terror still sometimes, of every year after you got your compliance, you're dragged into a room by an auditor and being told to show on demand things like your access logs and your audit trails, and how can you be sure and understand who has access to things over time. And so now you're going to have to make sure every single part of your application that's making a decision around who's allowed to access what, whether it's allowed or denied based on their conditions, based on where they are, based on who they are, based on the roles and groups they belong to, you're going to have start logging this in a consistent format. So every decision needs to be captured, and you might maybe just use a logging library, or if you've got something like a Datadog or something like that set up, you could send messages off to those. But you need to, across your code base, make sure this is consistent and also logged in a consistent format, so it can be easily retrieved and can be pulled up for those scenarios where hopefully you have an incident, but at minimum being able to prove to your auditors that things are as they should be. And there's plenty of libraries out there. So we grow once again, and now we've got big teams, we've got feature teams, you've got cross collaboration, you've got common services that are used across different parts and different features, things like authentication, and you're very quickly in the world of microservices. And where you fall on the microservices versus monolith spectrum, it can't be denied that microservices is kind of where a lot of people end up. And now this becomes a real problem, because you may then start having like a recommendation model or an API that serves predictions. That's going to probably be in Python. You might have some service that's running in Java for data manipulation. You might have something running in .NET for like a legacy enterprise integration. So now all this authorization logic and auditing and logging now needs to be replicated in each of those services. So that the recommendation API can also check whether the user is authorized to access those recommendations. It needs to be mapped. That's in Python. It needs to be mapped into .NET. If you're integrating some legacy enterprise system, it might need to be mapped into Java for the data manipulation layer, whether it's allowed to fetch it. So now this authorization logic is now replicated everywhere. Plus, anytime the requirements change, like you bring a new customer on board or you have a new restriction you want to put in place, all that logic needs to be replicated in each of those languages and kept up to date. And also the logging needs to be kept in a consistent format to meet those kind of compliance requirements you'll have. And this is where there isn't a library or a simple solution off the shelf to use here. And things get quite complicated. And this is where you end up having whole teams working for months on this. And I've done this in the past where we've taken 4 or 5 rockstar engineers and we've gone and built an authorization service. And I've had to do it 3 or 4 times because there was never an off-the-shelf solution. So what would a new approach be? What would be a way to kind of solve this? Well, we're in the world now of kind of the build versus buy or everything's as a service stack. The Jamstack ecosystem is very rich, and this is a very small subset from Redpoint, but it is vast in terms of the tools and frameworks and services that you can plug together and build a pretty comprehensive application just by sticking services together, and a great redistribution of VC funds that way between companies. And if we look at the utility API section here, one that's kind of dominated the authentication, not authorization space, has been Auth0. It's now the go-to authentication platform that you plug in and it just works. You don't have to worry about building that username and password database and the hashing, sorting, and the reset and all that logic. It's just handled for you as a service. And then your application just connects to that and gets the user's identity that way. What is not in this box right now is kind of something for authorization. We've got payments, we've got search, we've got backend APIs, we've got things like messaging with Twilio, etc. But authorization is one that's kind of trickier and is much more involved. But we believe that the time is right to kind of have an off-the-shelf solution which will deliver the same kind of experience for authentication that Auth0 does, but for authorization. So you don't have to keep building it over and over in-house and having to scale and get out that way. So what would this authorization as a service kind of look like? Well, inside your code path, you would have a request coming in, who the user is, they're trying to access something, some resource, they're trying to edit a blog, or they're trying to remove a comment, or they're trying to post an update. This authorization would take that context, and then based on some standardized policy definition, return you allow or deny. And this authorization would sit outside of your code base. It would be a service in your stack. And it would scale the application and it would be a consistent answer for who's allowed to do what, but also a consistent point where all auditing and logging can be captured. So the big thing here is we're going to a world where policy is better than code, or configuration is better than code, or greater than code in this case. And just as kind of an example, using a policy from the open source Cerberus system, being able to define your resources and the actions on that resources, and then the logic around who's allowed to do what. What role must you have? What condition must you have? What department are you in? These kind of things, or derived roles, kind of a concept of contextual-based authorization. And this is actually the world where you get into beyond role-based access control, RBAC, which you've probably heard of, and into attribute-based access control, where you're actually looking at the information about the specific resource that the user is trying to access to make your policy decision. So here we have a contact in like a CRM system, and we're saying that you're only allowed to read it if you're a user and you're in the Department of Sales, or you are in Department of Marketing, and the active attribute on that resource is set to true. So we're actually using context about the specific resource we can't access. And this is all abstracted out into configuration, very similar to like Kubernetes manifests, but it is compatible in this case. Where that logic can evolve and change over time without you having to touch a code base or the microservices in every language to do that. Just to call out as well to the kind of the Kubernetes ecosystem. this idea of extracting out logic into sidecar services that run as digital sidecars into your application is kind of the thing now, and is very much driven by Kubernetes originally. And there's solutions out there for things like authentication. So the OAuth proxy is probably one of the biggest sidecars that you may be aware of. But also things like logging and metrics, so the Prometheus sidecars and to go and capture metrics is a big one. And this is a useful model for something like authorization, because these instances are co-located together in the pod and in the cluster. So your network overhead is extremely minimal, and it will scale up and down with your application, and gives you a very fast endpoint where you can make these decisions. So it's not like calling out some external service over the web. Your authorization service would sit alongside your application instances, regardless of what language or framework those services are using, to get a response. So what is it like in practice? To give you an idea of what like a request flow would be. So on the left, you have your user in your application, their request is coming in. The first thing that happens inside your app is you've probably got some sort of authenticated session already in play. So you may have a JWT token, you might have some identifier that comes back from, like, say, or something like Auth0. And inside your app, you will kind of have access to that user's profile in the request context somewhere, or go and fetch it. The other thing is kind of the organizational directory side of things. So going back to the enterprise use case where you have roles and groups and teams and workspaces and subgroups, etc., all that context that your application will hold around what role someone is in or what team they belong to is all kind of available inside your application. You also have the data sources. So that request is trying to do an action on some resource. So editing a blog or updating content or publishing a video, these kind of things. And your application knows about those resource types. They exist in your database, maybe they're hidden some service somewhere to go and get it. But inside your code, you have the user, what roles they have, and you have the resource that they're trying to do some action upon, and you know the action based on the request. So rather than then inside your code base having that big if else case switch style statement to figure out who can do what across every service, you package up that information and send it across to some authorizing service. So you know who the user is, or say like the principal of the request. You know the resource, what kind it is, maybe some ID and some attributes about it. And also what actions they're trying to do. Are they trying to edit, recreate, delete, update, or something more granular like approve or moderate a comment or flag things? They can be pretty expressive of what's available and quite higher order business logic rather than basic CRUD. That goes off this kind of authorizing service, which then takes that context and makes decisions upon it. And what it uses to make those decisions are those policies I was speaking about earlier. And these policies are living somewhere outside of your code base. It could be in a database somewhere. It could be just a disk or an S3 bucket or something like that. Or it could be in a Git repo. And kind of the whole GitOps flow is very desirable for its repeatability and version control powers in there. And this authorization service would then take in those policies and start looking at the request and then making a decision whether someone is allowed or denied to do that particular action. That response goes back to your application, and then your application is simply implementing an if-else based on the response. If allow, then do the action. If not, deny and return some error. So in your response, you're returning kind of as expected. Now, because that authorizing service is sitting outside your app, it can then also log the decision before returning it to the application. So logging the incoming request and say whether it resulted in allow or deny, or maybe even some context around which policy was granted or breached the conditions before going. And that's where you will then connect it off to your Logstash or Datadog, something like that service to capture it. One other thing to call out is there's a problem or a challenge with having sort of an authorization system, which is around the listing and filtering use case. So if you have a million objects or a particular resource in your system, which is not uncommon in larger applications, you don't want to be fetching all million from the database and then filtering them down based on what they're allowed to. That's just not sensible. The amount of data we push around is kind of insane. So another type of API that you'll need back from this authorizing service is like, go and get me the predicates to apply to my database query or my fetching from some service to go to return just the items or just the resources that this user is authorized to access. And that's what some sort of query plan or AST type response would give you, where your application can then convert that into a SQL where clause or a Mongo filter or things like this to go and get just the results back that the user is allowed to access before returning to the application. So you kind of need both. You need kind of the definitive, am I allowed to do it? Or you need to be able to get the response back, which says, here are the conditions that you need to apply in your SQL query to just return what the user is allowed to. So this is kind of like a high-level diagram of kind of how the request flow would work. And you've probably seen the Cerberus logo there, but what this really looks like in your code, before where we had that if-else logic, etc., you now have something that looks like this after block, where you're just simply making this, is the user authorized call, and you're passing in the user, the resource they're trying to access, and the actions they're trying to take. All that logic happens inside of the service, and your application comes back with a yes, no, and this could be implemented in any language. So when you have your recommendation API in Python, or you might have some legacy code in .NET, being able to just go and hit this authorization service and get back the response, which gives a very simple response, that simplifies it massively. And also what's quite now important is your policies can evolve independently of application code. So you have a new requirement come in, you have a new feature land, and you want to change who has access to it. You can do that in your policy definitions, and that will be then effectively applied to all your services that are calling this authorization service to get a consistent response across your stack. So advantages and challenges with this approach. Advantages is logic is defined centrally, policies evolve independently. You are now agnostic to whatever framework or languages or architectures you use, as long as they can make a call out to this authorization service, it will work. You now have your policies in something that can be version controlled, so very GitOps friendly, and you have that consistent audit trail, which to meet those compliance requirements makes your life so much easier. Trust me, I've been in the hot seat literally with audits over the years, and this, if I had this, it'd be the dream. Now there are some challenges. Obviously, it's not there's not a one size fits all. You're going to have another service to deploy and run. You want this to be running in your infrastructure purely for latency reasons, unlike authentication, which you can cache for a session, say an hour, a day, a week, whatever. Authorization is in your critical code path for every single action that the user does. And you need to be able to deploy this and have it run as fast as possible. So things like the sidecar model, the Kubernetes world, really benefit from this. And also there's kind of there is a new DSL for writing policies in some cases. You need to go and get your head around how to convert your business requirements into policy definitions. But there are approaches which hopefully makes this as easy as possible. So just to wrap up, hopefully this gave you some ideas of a new approach to solve some of the headaches that I've seen over many, many times at different companies, and hopefully they resonate with you as well. Just a quick shout out for Cerberus. This is the project we're working on to give you this open source plug and play access management tool for your system. So that authorization service we've kind of spec'd out and defined here is available. Cerberus.dev is a website. It's also all open source, so you can check it out on GitHub also. And I'd love to chat and speak to some of you after the session. And that's it. Thank you very much.